Welcome to This Old Bus and thanks for watching. Today's video is about a build of a Raspberry Pi 4 that I made specifically for my bus conversion. I had several requirements for this build, but the main things are I wanted the unit to be able to shut itself down if it loses power cleanly. That's a big problem in automotive use with the Pi. You have to be able to shut it down. You can't just remove the power on them or it corrupts the drive. The micro SD cards, they don't deal with that very well. And the other thing is I put an SSD in it. So the SSD lasts longer than the micro SD cards that everybody uses on these things. I already killed one micro SD card in this thing and I had to redo my build. So a solid state drive will be much more reliable and faster, and I can use it as a media server. So in the end, the build has a battery backup. I'm running it off of 12 volts. It shuts itself down, and it met all of the objectives except for one big caveat that you'll want to stay tuned to find out about. So I had a shipment of goodies arrive today from Amazon. These are Geekworm products. I've got a case. I've got a batteries. These are some lithium-ion batteries. A power supply. This is a UPS control board that allows the Pi to shut down if power is lost. And I'm also hooking up a USB SSD drive to my Pi. This results in faster operation and better system stability because the Pi runs off of a micro SD card and they wear out over time due to the write cycles. And I've also got a little SSD drive that I'm going to be installing here. This is SATA. I didn't need anything fancy. You know, I could have went with an NVMe drive or something, but I mean, this is perfectly adequate. 240 gig. I got a good Kingston. So today I'm going to be assembling these components and also configuring my Pi to automatically shut down if the power is lost. Okay, I've assembled the SATA board and installed the drive, which goes on the underside. Just a couple little standoffs. The short standoffs go on the bottom because that's where it bolts into the case, and then the top standoffs, the Pi is going to attach to here. Okay, so now I've attached the Pi with these standoffs, and yes, they are shorter than you would expect because the UPS board just fits in this area here. It doesn't extend past this. So now I got to install the UPS board. That just attaches with the 4 screws. I got that on there. And it's kind of nice how it's got that fan to, you know, keep the Pi cool there. Right on the processor. That's the heat sink there, so that's cool. Nice. So the case is held closed by these 4 screws here. And inside we have a fan and a switch and some screws. The whole thing is held in by 4 very small screws on the bottom here. I'm not showing the assembly, you know, going together because Geekworm's got a 6-minute video on this, or 7 minutes, and it's probably a lot more concise than watching me fumble around with this, but it's pretty straightforward so far. The fan is held in by 4 screws over there. Tightening these screws up, it's very dependent on the alignment of the standoffs on the other side, which do have a little bit of slop in them. So I recommend just you know, getting them started and then, you know, snugging them up, you know, kind of a little bit at a time. You work your way around, get them all lined up. Okay, I had some difficulty locating the correct screws in the kit to screw down this battery holder, and it appears that it's these little teeny countersunk ones. So I installed the batteries, observing the polarity, and I installed this switch and hooked up the wires according to the instructions, and the battery is charging now. Right there. Probably can't really see it because I've got my light on here. Let me shut my light off. Now you can see the little charge indicator's doing something there. But, kind of BS though, you can't see it in the case. There's no hole to be able to see that. So I consider that a design flaw. I'm gonna let this charge up, and then I gotta do procedure to get this Pi operating off my SSD, which is probably one of the more challenging parts of this project. Okay, well, I'm calling this a fail so far because their docs talk about USB 3 interference with your 2.4 gigahertz Wi-Fi, and I'm experiencing that. You can see here I've got these errors that were occurring in the morning, and then these pings down here. This is where I pinged my router, got no response, and then I was looking at some log stuff, and then when I unplugged the USB 3 adapter and waited a little bit, my Wi-Fi came to life. So I'm pretty annoyed by that, and that ain't gonna work for me because, you know, their recommendation is that you use your 5 gigahertz Wi-Fi, but I don't have 5 gig Wi-Fi in the bus. I've only got 2.4, and I mean, eventually I will have that, but I got to use 2.4 in a lot of cases, even in my house. Just because of the way it's laid out, I need the additional coverage. You know, the 5 gigahertz doesn't get there range-wise. So I am going to try wrapping their stupid little adapter in some foil wrapped in electrical tape here to see if that helps the problem, but I am not very optimistic about that. Alright, so I got the software installed that allows me to run off the SSD. Well, basically, it involved flashing the firmware on the Pi, following instructions online. It involved reinstalling the operating system on my SSD, essentially. And then I installed the shell script from Geekworm that enables this to power down the Pi. And I can go ahead and demonstrate that here. Well, before I do that, let me explain something here. So this USB 3 effectively knocks off your 2.4. I've already talked about it. I've tried doing some stuff like, you know, wrapping this in electrical tape and tinfoil sandwich. I tried laying something in here to, you know, try and mitigate the interference between this poorly designed SSD adapter to the Pi's Wi-Fi. You know, if I really wanted to get all technical about it, I could probably make a sandwich in here of, you know, grounded shielding material between this board and the Pi. I could potentially do that. I don't know if it'd solve the problem or not. So just as a workaround that I can kind of live with for now is just running it off the Ethernet. If you have 5 gigahertz Wi-Fi available, then that'll work for you as well, and that's not a deal stopper. Alright, here's the fully assembled unit. Tinfoil optional, doesn't matter on that. So we got a nice power button here that has 3 functions. It enables you to, if you press it for less than 3 seconds, between 1 and 3 seconds, it will reboot the Pi. If you hold it for 3 to 7 seconds, it will do a clean shutdown. And if you hold it for longer than that, it'll do a forced power off. That's your micro SD card slot, which is not in use now because I'm running off the SSD. This power jack is the one that you use. This is on the UPS. The reason why is you want to be careful to not power it through your micro USB inadvertently, or sorry, your USB-C, because that'll screw things up. You can also power that UPS board with the USB-C here. And then, of course, you know, your USBs and Ethernet on the back, some unused stuff there. So I'm going to go ahead and demonstrate this operating off of battery and also shutting down. Okay, it's powering up now off the battery, and it boots pretty quick. We'll boot up into Raspbian Desktop here, and fully running in 20 seconds. Let's say 23, 24 seconds. Okay, so now I'm going to go ahead and press this for 4 seconds. 1001, 1002, 1003, and it already did it. So as soon as it hit the 3 second, it's doing a clean shutdown now, and this light will spin to indicate. And then when it's done, the fan shut off and light shut off. So I'm going to be running this headless, and so that's really, you know, convenient for me. So now, note, you know, the power is not plugged in right now. We're just doing this off a battery. I'm going to go ahead and boot it up again. This time, I'll do this. I don't need to demonstrate the reboot function. I'm curious how much faster that boots, you know, compared to those of you running off micro SD, you know, all the way up into Raspbian like that. So there's a Python script in here you can run to make sure that the unit is detecting loss of power and will properly shut down when the battery level goes down. So I'll go ahead and do that now. I'm going to pause the recording for a second to then come back and show you the output. I plugged it in, and the first 4 here are, I guess, it telling me that it sees that it has power. Now we're back to a power loss situation. I unplugged the battery and it's doing that. So these are 18650 batteries in here. They're rated at 3.7 volts a piece. There's 2 of them. This script will tell you what the voltage is. Now we know the Pi needs 5 volts to be happy. So I don't know if this indicates the battery voltage or if this is the voltage the Pi is attempting to run on. It must be the battery voltage, because I don't think the Pi would be working too well at that level. So I ultimately got it running, and I'm using Ethernet instead of Wi-Fi to power it. I am using a USB-C to feed the power from a high output cigarette lighter. So this cigarette lighter claims to be able to put out, I don't remember if it was 3 amps or 5 amps, but it's, you know, it's rated for a Galaxy S20 phone. Got it off of Amazon. So it's running on 12 volt, or running on 12 volts off the cigarette lighter, off the Ethernet, over to my router, and it's working well. And I'm running it headless, so I can power it off. If it loses power, it's going to shut itself down cleanly. So yeah. Thanks for watching, and hope you liked the video.